So here I'll call R as the number of days that Ramesh takes to complete this work, and then G is the number of days that Ganesh takes. So the first setup is that their individual rates, which are the reciprocal of the time it takes them, is equal to 1/16th, which is their combined rate. Now the second setup comes from here, that they've first worked for 7 days. So this is the fraction of the work they've already completed. Then Ramesh's efficiency falls by 30%, which means if his rate was 1/R, it would become 0.7, 70% of his original rate. Now they continue to work at this new combined rate. That's Ramesh's rate plus Ganesh, and they would then do this in 17 days, so 10 more days. So that's the additional fraction they've done in 10 days. So again, this has to come out to 1 because they've completed the job in 17 days. Now we'll come to that, but first we need to figure out how many days it takes Ganesh to do this job. So we have these two equations. I mean, it's some algebra here. I'll distribute the 7. So this is a matter of how quickly you can do this. And then distribute that 10 equal to 1. And then I'll combine these two terms. That's 14/R plus 17/G is 1. I'm going to divide this by 14, both sides. Why? Because I want to then get rid of 1/R term. Maybe other ways to do it, but this is sort of how I went about. So I have this equation. I'll stack that one and then subtract them to get rid of R term. So this would become 17/14 minus 1, and then 1/G, 1/14 minus 1/16. This becomes 2/14 times 16. I'll leave it in that form. This becomes 3/14, because this is, I combine that fraction here. Then knock that out. Then 2 goes into 16, 8, and then cross multiply. G is 24. Now the question is, if Ganesh had worked alone after Ramesh got sick, in how many days would he have completed the remaining work? So I need to know what fraction of that remaining work needs to be done. So I actually need to find R. Originally I thought maybe I don't need the R. So I'll plug that in here. So 1/R is equal to 1/16 minus 24. You'll see common denominator 48. So 1/48. So R is 48. So had worked alone, how many would have completed the remaining work? So I can figure out that fraction of work that they completed in those first 7 days. So this is 148 plus 2/48 times 7. So that's 3/48 times 7. So they've done 7/16. So Ganesh has to do the remaining, which is 9/16 of the job. And his rate is 1/24. So I multiply that by time. This will be the time to do that remaining job. So T is 9/16 times 24, 27/2, which is 13.5. Answer choice C. So just a comment, I mean, it is fairly involved. I mean, there is not only just setting up these two equations, but also doing the algebra to solve for the variables, and then also find what fraction is left. So it's actually, there's quite a bit of work in this question, and can be difficult, of course, when you're doing this under time and pressure. But make sure you can set up these equations. Of course, that's the central part, the most difficult part here, and then the algebra, of course, depending on how quickly you can do this. But this is a very standard work problem, so that's a good example.